Hey everyone, welcome to another ALEKS tutorial. In this one we're going to be looking at some more periodic trends. So this one is understanding periodic trends in atomic size. So this question says reorder each list so that the atoms or ions are listed in order of decreasing size. So when we are comparing by size, we want to be looking at the trend of as we move to the right on the periodic table, we are getting smaller. So that's smaller atomic size. And as we move up on the periodic table, we are also getting smaller. So that leads us to a trend. You could make this diagonal trend here, which is decreasing size. And that makes sense, right? Because take helium, for instance, which is our smallest atom. In an atom of helium, there are only 2 electrons surrounding the nucleus. And those 2 electrons are going to feel the full force of the magnetic attraction between the nucleus, the positively charged nucleus, and the negatively charged electrons. And so they are going to be very strongly pulled together. Compare that to something like francium, where it's got 87 of these electrons, and the last electron is in its S1 state. And so that's going to have an extremely weak attraction. So if this is the nucleus, the electron's going to be all the way out here. And that leads to a bigger atomic size because there is a bigger gap between the nucleus and the electron. So with that in mind, let's clear the table a little bit and look at what we have in this problem. So we have carbon, fluoride, and beryllium. So beryllium is here, carbon is here, and fluoride is here. So fluoride is going to be the smallest, and beryllium is going to be the largest. So if we order these in decreasing size, we're going to start with beryllium, and then we have carbon in the middle here, and then we have our smallest, fluoride. Let's do another color for the next one. For the next one, we're only dealing with 2 elements because we've got ions in here. So for the next one, we're dealing with chloride and or chlorine, sorry, and bromine. So chlorine's here, bromine's here. As we go up on the periodic table, we're getting smaller. So bromine is the smallest, and chlorine is the largest. However, we have an anion here. We have Br minus. So what does the minus mean? The minus means that compared to neutral bromine, there's an additional electron orbiting this atom, and when you have more electrons than neutral, you're going to have a negative charge of some sort. And so if we have more electrons than neutral, that just adds more size to our atom. And so in this case, Br is going to be of a larger atomic size than Br. Br minus is going to be larger than Br neutral. So if we're ordering in decreasing size, we would start with Br minus as our largest, and then Br, and then chlorine. I just realized, very stupid, I got these the wrong way. They should be bromine is the largest, chlorine is the smallest. Sorry about that. Don't get dyslexic like me. Moving on, we have Al2+, aluminum 2+, aluminum neutral, and magnesium. So magnesium is here, and aluminum is here. Without making another mistake, we can see that magnesium is the largest, and aluminum is the smallest. And we have to compare aluminum 2+ to aluminum neutral. The 2+ indicates that we have 2 electrons removed from neutral aluminum, giving it a net positive charge. So aluminum is going to have more radius surrounding its nucleus because it has more electrons. And so aluminum neutral is going to be larger than aluminum 2+. And so if we're ordering in decreasing size, we have our largest, which is magnesium, followed by aluminum and aluminum 2+. And you know what? These problems are annoying. I remember when I was in Chem 60, all of it, this would happen all the time. And it's usually because you got to be very careful with these, especially if you're a little dyslexic like me. Ordering from decreasing size and knowing that it gets smaller as you go in this direction, sometimes your brain just flips them. So double check and make sure that your answer makes sense. And so learn from my mistakes. Don't do that on a test. Alright, thanks for watching. See you in the next video.